Hello everyone, I'm Nex and welcome to our lesson number 2, Algebraic Expressions and Polynomials. So before we begin, an algebraic expression consists of numbers, variables, and operations. The operations are addition, subtraction, multiplication, division, and exponentiation. As for the key terms I may mention in this video, they are coefficient, which is a number or constant that is multiplied with a variable. A variable is a letter, symbol that can be replaced with any number or whose value we want to calculate, for instance. So if I had an equation of 2 plus 2 is a would be replaced by a 4. Constant is a fixed number that is added or multiplied, most commonly working with a variable. So 3 times x, 3 is the constant and x is the variable. Together they form a term. So a term is a subgroup of sorts inside of an expression. So we have an expression 7x plus 3, then 7x is one term and 3 is the second. So the terms are separated by plus or minus signs, and when all the terms are added together, they form an expression. So a phrase called like terms will be mentioned later on in the video, which means we take out a part from the term that is equal in other terms that are nearby. So for instance, like we found the greatest common divisor, we will do the same thing here for the term. Then the degree of an expression is determined by the highest exponent of the variable. So if you have an equation like x squared plus x cubed, the x cubed is the highest exponent, so it's a third degree expression. So before we actually begin, it's important to remember these following rules, that if you put brackets and an exponent over them, if the exponent is even, then any negative sign inside the bracket, like so, will disappear. So in brackets, minus a squared equals to a squared, so the minus sign disappears. If we put an odd exponent, so minus b to the power of 3, we will get the result of minus bracket b to the power of 3. So here I put out the steps to what each of these notations mean. So what difference do the brackets make in exponents? Hopefully you can remember this, because a lot of people don't know them, and it's very important to know all of this before we continue. So these are the rules for exponents. If you have an exponent over an exponent, if you multiply two numbers with exponents, of course if the numbers are the same, if you put b to the power of y, it wouldn't work. Then we have division, which basically subtracts the exponents one from another. And if you multiply two different numbers or variables that have the same exponents, you can put the numbers into the brackets and then put the exponent over the entire bracket. And we will see exactly why this works later in this video. A couple of last things, because I changed some notations later on. If I put x to the power of minus 1 and if the exponent is negative, it means it's a fraction and the x is in the denominator. And it should help us stay in the lines, because I'm making the PowerPoint, as you can see, because I found out syncing up the iPad writing and me talking pretty much impossible, especially with the lag. Hopefully this video is better. So, simplifying algebraic expressions. First chapter, combining like terms. For instance, if we have an example like 3x plus 5x minus 2x, how do we start solving this? Well, we see that they all have one thing in common. That thing is x. So like in prime factors, if we assume x is such a factor, we take it out and calculate the rest separately. Meaning if we take x out, we could multiply x with each individual number to get this back. However, we did the other way around, so we can add the numbers together. So we get 8 minus 2 is 6. We get 6x. And example number 2. So we learned the rules last time, meaning we can move around the terms as long as we preserve their sign in front of them, and that we don't break apart multiplication if we're moving addition. So if I take plus 7a, I have to move this entire part to whichever location I want, except in between these two, so I can't make it 4 times 7 times a squared, if that makes sense. Hopefully it does. So I decided I'm gonna put minus 2a squared to the left, so I calculate a squared together and a's together, because technically they are different variables. So we put these two in the brackets, and we put the other two in the brackets, so it's easier adding them together. If we take out the common term, we would take a squared, put 4 minus 2, we get 2, and we will have 2a squared, but we're moving forward, so we will just do math as we usually would without taking unnecessary steps in between. So we would get 4 minus 2 is 2, so 2a squared, and 7 plus 3 is 10, 10a. This is the final result. Now, example number 3. Something's a bit different. You see, we have 2xy plus 3xy minus yx. Can we add these together? Yes, because we learned that, as with terms, the order of multiplication doesn't matter as long as we don't move it too far apart. So we can't take this x and move it here. However, we can change the order of x and y and rewrite this equation as, or expression, as 2xy plus 3xy minus xy. So now we have two variables. Do we know if we can add them together like we did with one variable, or do we have to do something more complex? Well, we can simplify the process by replacing the variable xy with a, for instance, which gives us the following expression form, 2a plus 3a minus a. And this is very simple maths. We did 2 examples already. We get 4a. Now we replace a with xy, and this is our result. So now we learned that you can substitute certain constant parts with a different variable, as long as it makes sense. We may not use this as much in my videos because, well, I will try to make stuff as easy as possible without any unnecessary complex equations. But when we get to physics and maybe chemistry, that's when this exact thing will come in very, very handy, because you can replace a big part of the equation with just like a variable and just saves us a lot of time and space. So now we return to the distributive property. I won't let you forget this one. If you multiply anything by something in the brackets, you get the spread out formula of that. For example 1, 5 times bracket 2x plus 3 equals, we multiply 5 with 2x, we get 10x, and we multiply 5 with 3 and we get 15. Simple. Now there's a step up. Now we have to respect this, the signs in front of numbers. So if we have minus 2 times y, we would get minus 2y. And if we multiply minus 2 with minus 4, we get plus 8, because minus times minus makes a plus. Okay, all simple. That was just repeating. Now we get to the actual example that will come in handy to whatever we need today. If we have two brackets multiplied by each other, we can solve this several different ways. But the most commonly used one and the easiest one, and probably the fastest, will be by going in order. So you take the first one in the first bracket, so let's take x, and multiply it by each of the terms in the second bracket, so with y and with negative 3. So multiply x with y, add on that x times minus 3. After that, we move on to the second term in the first bracket. We multiply that with the first term in the second bracket, so 2 times y. And then we multiply whatever is left, so 2 times minus 3 is minus 6. I hope this makes sense, because this is what we will be doing for the rest of this video. Most of it, at least. We will be using this exact rule by going in order. Don't worry, I will repeat it several times again and color code it so it will make more sense. But this is just what we will be doing. Now we can move on to special binomial expansions. Now, these are all complex words. Binomials, they're basically equations. I will tell you more about what they are, but expansion just means if you have a short form of something, so like a bracket multiplied by something, you just break it apart. So no more brackets, no more exponents over brackets, etc. So the longest form possible. Why would you want it? Well, sometimes it's useful. Most of the times you wanna shorter it or factor out stuff, but it's important to know expansions as well, because, well, as I said, you will need to use it someday. First of all, the first important equation that pretty much everyone should know is the square of a difference. So difference between two numbers, variables, in brackets, then squared. Okay, so this is the formula for it. A minus b all together to the power of 2 is a squared, as we're going step by step, We multiply a with a, we get a squared. Next up, we multiply a with negative b, we get minus ab. Now we multiply the minus b in the first bracket with the a in the second, we get another minus ab. And now we just multiply the two minus b's together, we get plus b squared. Now we have two of the same variables, so ab and ab are repeating what we learned a couple of examples ago, that we can add those two together without complicating too much. So we get a squared minus 2ab plus b squared. The same thing can be done for square of a sum, so a plus b to the power of 2 equals to a squared plus 2ab plus b squared. I hope you notice that there is a slight difference between the two, and this difference stems from the rules that I established at the start of the video. So if there's a negative sign in the brackets, if you square it, it will disappear, so there's a plus b squared. However, since here there's only one b, it will take this negative sign with it. So it was, if we put b to the power of 5, the minus sign would stay. If we put it to the power of 4, it would go away. But now, why does this exactly work? We did the mathematical part, now let's take the graphical part so it's easier to understand it visually. Let's assume multiplication can be presented graphically. So if we take a rectangle and we label one side as A and the other one as B, then we all know that the multiplication of two sides of the rectangle gives the surface, so A times B. But what if we were to change that? We made a square where a side is A plus B and the surface is A plus B squared. So this formula would mean the surface of the entire square. Let's take a random distance, let's put it right around here, and label that as A. And then the rest should be B, if the entire distance is A plus B. Now we have 4 sections. The first one is A times A. The surface of this is A squared, and we'll label it as 1. Second is B squared, which we'll label as 2. And then we have 2 rectangles that are identical to each other because they have A times B surface, and they're just rotated, so we will label them as 3. And now if we put out the formula here, we break it apart, so the surface of this entire square is like this, and it has to be comprised of these 4 compartments. Compartment number 1, which is A squared, compartment number 2, which is B squared, then compartment number 3 for AB, and another compartment number 3, AB. So if this all equals to the surface of the square, which graphically we've proven it does, we can add these two together, form it around a little bit, and we get the formula we put out mathematically before. So this is the second proof that a plus b to the power of 2 equals to a squared plus 2ab plus b squared. Also, hopefully it doesn't bother you if I say to the power of 2 or squared interchangeably, because they mean the same thing. I'm just trying to avoid repetition, so if I keep saying squared, 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 it becomes annoying. Now, for the examples of said special binomial expansion, we have x plus 4 squared. So if we remember back how the formula went, we went x squared plus 2ab. So 2 times 4 times x is 8x, and then b squared, or y squared, whatever you go with, is 4 squared, which is 16. Now for example number 2. This one's a bit more complicated, but don't worry, it's very easy. We square the first part, we get 9a squared minus 2ab, because we see there's a negative sign here. So minus 2 times 3a times 5. 3 times 5 is 15. 2 times 15 is 30. Minus 30a. And lastly, we have minus 5 squared, which gives us 25. Now, next up is a cube of a sum. I won't really go into graphical because the cube is a 3-dimensional body, and since I don't have much experience in 3D modeling, I won't embarrass myself with it here. I will write out the formula mathematically, and let's take a strategic approach to it. We can break apart this as a plus b times a plus b times a plus b. Basically, the bracket of a plus b multiplied 3 times. However, we already know what a bracket of such form when squared gives us. So let's write it down as a plus b times a plus b squared. let's break apart the a plus b squared by the formula we just got from the square, from the visual and mathematical proof. And let's color a plus b with separate colors, so we will keep track of what we have already multiplied and what we didn't. We will multiply a with each of the terms in the second bracket, and then we will add on b multiplied by each of the terms in the second bracket. So, if we multiply a to the a squared, we get a to the power of 3, or a cubed, plus 2a squared b, plus ab squared. I'll put this in blue brackets and color these two separately. We will see why in a second. Now we multiply b with every single one of these terms and add together. So we have the blue bracket, which stems from a multiplied by this, and the green bracket stemming from b multiplied by the second bracket. Now you can see there's an orangish color on a squared b and a grayish color on ab squared. That's because we can add these together. So if we add these two together and we add these two together, we get something like this. And this is the final formula for cube of a sum. So it's the first one to the power of 3 plus 3 times first variable squared times second variable plus 3 times first variable times second variable squared plus the last variable cubed. We can do the same thing for the difference, so a cube of a difference. If we go by the equation and we follow the rules that negative b when cubed gives a negative sign, we get a cubed minus 3a squared b, because b is to the odd exponent, plus 3ab squared, now the negative sign is gone, minus b cubed, which is the formula for the cube of a difference. As we're zooming through this lesson very fast, let's slow down and learn how to factor out the greatest common factor, or GCF to shorten it. We learned factoring out the greatest common divisor, which is another abbreviation or whatever the word is. Now we use the same thing, or the same principle here. We will factor out not just primes, because, well, they're not always going to be primes. Sometimes they're going to be greater numbers, and we don't know if the variable is a prime or not. So we just call it a factor, or factoring out the greatest factor. And in this example, let's do it tactically. So from both of these, we can see that they both share an x, and they're both divisible by 3. So let's take out the common term of 3x. If we divide 6x squared by 3x, we get 2x. And if we divide 9x with 3x, we get 3. So this would be the final form of the first example. Solved. Now for example number 2. We see that all of these three terms have the same factor, 4a. So we write 4a and then put brackets. If we divide 4a cubed with 4a, we get a squared. If we divide 12a with 4a, we get 3. And if we divide minus 8a squared with 4a, we get minus 2a. And since 24 has no a in it, we just write that forward. But now we have a weird mess. And we see that 24 and 4 are also divisible by the same number, 4. We could do that at the start, but we took a out before as well. So if we went from outside in, we would first take out 4 from the all 4 terms. Then from the first 3, we would take a, and then keep on solving. But this way we'll get essentially the same solution, but in a different way. So we take out the 4, and we write from the first part, which all of this is the same term. We will just copy it and put it inside of a separate bracket. So we copy this in the first part of the bracket. I use the square brackets because it's just easier to see which falls in which priority. And after that we have 24, which divided by 4 gives us a 6. So we just write that down in the same bracket and close it off. However, if we move minus 8a squared forward to group it together with 4a cubed, and then we group together 12a with minus 24, I see something that you probably don't yet, because I have enough mileage of mathematics behind me. And I promise you that when you get so far, you will probably see it too. But that's why we learn. The more you learn, the more you know. So let's start from the beginning. The first bracket, they have a common factor, which is a 4a squared. If we take it out, so if we divide each of these two, we get a minus 2. As for the second bracket, we can factor out 12, which gives us 12 times a minus 2. And this is exactly what I saw. A minus 2 repeats in both of the terms. You see, because they are separated by a plus. Meaning that we can take it out as a factor again. Well, in this case, we can take 4 times this bracket, because they both, so 12 and 4 are both divisible by 4. So we write out this factor in front, and then we put in the brackets what's left. So from the first part, we have a squared, and the second one, 12 divided by 12 divided by 4, which is 3. So a squared plus 3 is left, which is the final result, which is very mindful, very demure. You see, it looks beautiful. There's 4 parts of it that when multiplied together give this mess. So factoring trinomials, which are quadratic expressions. Now you may be thinking, what kind of magic words are they? Do they make IKEA furniture float? Well, I hate to disappoint you, they don't. They're just mathematical words for something that it's not very complicated in theory, of course, or on surface, which is what I'm showing you guys. So the important part is the quadratic form of an expression. This is how it looks like. We take a multiplied by a variable to the power of 2, plus b multiplied by the same variable, plus c. Now, either of these can be 0, so a formula of x squared plus 2 is in its quadratic form because b is 0, and 0 multiplied by x is 0. Now, this may seem familiar. There are 3 terms. The first one has x to the power of 2, the second one has x in it, and the third one doesn't have x. If we remember to the square of the sum, we will remember that we had a formula as a squared plus 2ab plus b squared. In this example, a is x, and we just take b as some random constant. We see that a squared can be similar to x squared, and 2ab can represent bx, so 2b would be b. And for c, well, that's just b squared. A, b, and c are usually replaced by numbers, and we only have 1, maybe 2 variables, but we always point out the one that is present in the x to the power of 2, x to the power of 1, and x to the power of 0 form. Since number to the power of 0 is equal to 1, we don't need to write it. What's important about this form is that we can write it in a certain form. If we take inspiration from the square of the sum, we can write it down by replacing b, or y, or whatever the second variable is, with 2 different variables, n and n. This is also known as Vieta's method. There's 2 parts of it. We will only cover the first part here. The second one will be present in functions or before them when we work with the quadratic function, because that's where it's more useful. But if we use this template that I've written down here, we can see that when we multiply the 2 brackets together, we would get that m times n should give us c, and n plus m should give us b. As if we multiply it, we would have mx plus nx. The sum of these two would be m plus n. That should be equal to b. However, this only works if a is equal to 1, because, well, there's no coefficient here. And a actually influences this a lot. I will show you this in a couple of examples, but let's just solve a simple one first. We have x squared plus 7x plus 12. Well, how can we approach that? We use the knowledge that we already have. Which numbers divide 12? And which two numbers especially, when added together, give us 7? Well, we see that 12 is divisible by 1, 2, 3, 4, 6, and 12. And 7 can be compounded of 1 plus 6, 5 plus 2, 4 plus 3. And we see that 4 plus 3, when they're multiplied to each other, they give us 12. And how do we know there's only 2 terms for it, so 2 numbers add together giving us 7? Well, x squared gives us 2 brackets, and when we add 2 numbers together, we should get 7. So, we have 2 terms, 3 and 4. Since there's addition, there's no complications, we can just write this down as x plus 3 and x plus 4. For example 2, we have a bit more of a complicated situation because we have a factor which isn't equal to 1. But let's approach this simply. 2 can be divisible by 1 and 2. Okay, so we're gonna break it in 2 brackets, where one is written as 2x and the other one as 1x. And this is how it looks like. We have to determine what m and n are. And since we have -3, the signs in front of the numbers will also be important. Now, since solving multiple brackets like this is a bit hard, we will just multiply terms together. So 2x times x is 2x squared, 2x times m, so 2x times m gives us 2mx, then n times x gives us nx, and n times m gives us mn. If we rewrite this down again, and take out the x from the two factors in the center, we would get 2x squared plus x times bracket 2m plus n. And now, before we continue, we can switch the order of these two, so we put x behind the bracket, so we have a similar form like here, so there's a number multiplied by x. And now we just add over m plus n. Now we have an equation. 2m plus n has to equal 5, because this part is the same. And the second equation, we have mn equals to minus 3. We haven't really covered multiple systems with multiple variables, but in this case we can just assume like this. If m and n have to be multiplied into minus 3, which numbers can that be? Well, minus 1 and 3, and minus 3 and 1. If we trial and error this into the bracket to get 5, well, if we multiply some number with 2, and then add another number, we have to get 5. So if we multiply 3 with 2, we get 6. If we take away 1, we get 5, which is correct. But if we multiplied minus 1 with 2, we would get minus 2. Plus 3, we would have plus 1, which would be a completely different equation. So, the result being, if we fill out the numbers, of course, we saw that m has to be 3, and n has to be minus 1. So if we move the signs and the numbers in the correct spots, we get 2x minus 1 times x plus 3. And this is the final result of this example. Moving on to one of the last chapters, the difference of squares. So the formula is as follows. A squared minus b squared is a minus b times a plus b. Why does this work? Well, let's do the math. We write down the brackets and we color out the letters so we know and we can keep track of which was multiplied with which. So we multiplied the blue a with green a, we get AA or a squared. Then we multiplied the blue a with the orange b, we get plus AB. We multiplied the pinkish b with the green a, we get minus BA. Then we multiplied the pinky b with orange b, and we get minus b squared. Problem is here, because I color-coded this, however, you have to keep in mind that both of these values are the same. So are both of the b's, all of the a's. The colors are there just to make it easier to see that we multiplied everything together. And now, before we keep doing anything, we can change the order of a and b so it's easier to calculate with them. And now we see plus ab minus ab. If we replaced ab with an x or y, we would have plus x and minus y. When we add plus of a number with a minus of that same number, we get 0, as it was mentioned in the previous video as well. So we can cross these two out, and we multiply a to the a and b to the b, which gives us a squared minus b squared, which is the final result. Now, for the example, we see that 9 is a square of a 3, and x squared is square of x. So if we follow this formula, we just replace a with x and b with 3. We get x minus 3 and x plus 3. Now for the second example, slightly more complicated, but not really that hard at all. We have 4a squared minus 25b squared. These are big numbers, however, if we know that 4 is the square of 2 and 25 is the square of 5, we can simply solve this as 2a minus 5b and 2a plus 5b. Well, let's approach the end of the presentation. And by the end, I mean another 30 slides. Common mistakes that people make. The first common mistake is one of the biggest ones that people make, is distributing exponents incorrectly. So, we all know this lovely equation of a plus b squared. It does not, in any of the universes, equal to a squared plus b squared. If it did, mathematics would be a very different branch from what it is today. How different, we can't tell, but we do know that this is not how this reality works. So whenever you come across either of these, if you come across this is not the solution, and if you come across this one, the other one is not the solution. However, this is the correct form. We said it in the video. You will use it in your life. Hopefully you remember that there's a slight factor here that you should not forget. The next sin is forgetting negative signs when expanding or factoring. And this is a horrible sin, which the negative signs always cause big problems, especially if you forget them. In this case, the guy solving them forgot several things. First of all, when you square a negative number, you get a positive, so -9 is already wrong. However, it's also missing another factor in it, or another term, and I'm guessing the guy just canceled them out, saying that plus 3x and minus 3x cancel each other out. However, the guy solving this also forgot a crucial thing, the term between them. He probably thought that minus 3x and plus 3x cancel each other out. However, if he paid any attention to my lesson, he would know that you don't get plus minus, you get 2 minus x3s, which results in minus 6x, which is the final good result. The next problem that many people do is that they don't check for the common factor before they start applying trinomial factoring. Well, let's see why. We have this given equation and we can see, okay, we can break down 18 and 12, 12 into numbers that can be added up to 12, and 18 into numbers that can be multiplied together to get it. And with some time, we get this result, which, while correct, is not the best or the easiest solution. While it is correct, it's not the best or the easiest solution. Well, why? When we get to the function, you will see why this particular part is relatively pointless. I mean, at the same time, you could factor out after, but you're just making yourself bigger problems because you have to account for this factor in here and all of that. It's just a nuisance. So how would we actually solve this? First off, we would take out 2 as a factor, and we have a simple... and what is left is just a simple form, which gives a simpler expression, which is x squared plus 6s plus 9, and we can just factor that into x plus 3 squared, which gives us a very pretty result. That's just absolutely wonderful. On to the next sin and mistake. Be careful when applying difference of squares. X squared plus 9 definitely isn't a difference, and is vastly different from this, because as we all know, this equals to x squared minus 9. But does x squared plus 9 have any solutions? Well, yes, it does, but it's not solvable with real numbers. It's solved with complex numbers, which are a separate lesson altogether. If you want the solution, this is it. I won't really explain it yet, because there's a separate lesson, which will probably have more time than I have, because I already wasted like 40 minutes of your time. But yes, let's move on to the incorrect signs in the not the domain expansions, the cubic expansions, and the square of difference, of course. Let's say we have a problem of a minus b cubed. And people again forget the signs. I could have put this earlier, but the cubic expansion is more problematic, especially because it has higher exponents and it's just a bit more of a snake to write. So this does in no way equal this, because we didn't put any respect on the sign in front of b, meaning that b to the power of 1 here should be negative, while b to the power of 2 here should be positive. So if we move these two around, we get the correct equation or expression. So b to the power of 1 is negative and b to the power of 2 is positive, while b to the power of 3 is negative again. So always be careful what the sign in front of the term is. As we see in the square of difference, that b to the power of 1 contributes to the negative sign, and b to the power of 2 contributes to the positive sign. Now before we part, I have homework. Before the test, of course. After the homework, you will get screenshots of the test, so you can solve it, and after that a video with solutions comes up, so you can check if you solved it correctly. As for homework, using what you have learned today, you will try to get 2 formulas for sum of cubes and difference of cubes. We didn't really mention them, we didn't really cover them, but we did see the difference of squares. If you take inspiration from that, you can get pretty close to the solution. And we had the cube of a difference or cube of a sum. If you want to solve this without a hint, pause now and screenshot it. Otherwise, I'll display the hint, which will pretty much solve most of it for you. You just have to fill in the numbers. So here is the form of the solution. You just have to multiply the brackets, find what the n and x are for both the sum and difference, and just write it down and you'll get the appropriate formula. It may seem hard, but with the hint, it's very, very easy. And if you get stuck on it, however, it's not mandatory, of course, but I will link the solution to how to get it in the description or the comments so you know where you got stuck and how to get past it. Thank you so much for tuning in today. Here is the test. You can screenshot it now, start solving it. Solutions come up a couple of minutes before/after. And yeah, that's it for today. Thank you so much for tuning in. Have a good rest of the weekend and see you on our next quest. Bye.